Okay, for the second question, that's actually even easier. If you use the mathematical way to solve it, it's gonna be just a 1-minute job. So let's read the question. A company just paid a dividend of 50 cents, that's dividend 0, okay, and it expects to increase its dividend by 2% per year. The required return is 15%. Okay, how much the stock should be selling for, or how much the stock should be worth. So if you go to Excel, once again, we play the same old trick by simulating so many years. Okay, let's say we got 80, 58, that's not enough. Okay, let me just keep dragging to 200 years. And then the first year, the dividend will be $2. Okay, and remember, it will grow by 2% per year. Okay, so that's a $2 times 1 plus 2%, or 1.02. All right, and in the next year, the dividend will grow by another 2%, so that's the first year dividend times 1.02. Okay, so it's not a much big change. You see the dividend only grow by 4 cents, but if I double click or simply drag it all the way down, you see the dividend will grow to a much larger number after hundreds of years. And if I just add all the numbers together for all the future dividends, I would end with infinity. However, that's not the way it works. I'm going to discount all the dividends. Okay, so the first year dividends divided by 1.12. Okay, 12 is your discount rate. I'm sorry, it's a 1.15. The discount rate is 15%, and then raised to the power, you put a caret of 1. All right, so the 2.04 will be discounted to 1.77, and then the next year it will be discounted to 1.57. So as the time goes by, your dividends basically is discounted to $0. Okay, if you add all of them, of course you're adding a lot of zeros after several years, so basically that does not change your total sum. All right, so this is a 15.69. that's supposed to be your answer. All right, as I said, you can use the mathematical way to do it. That's just 1 minute of job. So you use the first year's dividend divided by 15%, which is your discount rate, minus 2%, which is the growth rate of the dividend. Okay, thanks to the mathematicians, this just work the same good. Okay, so it's the same result. Okay, both ways will do the job. So this way is more suitable when you do not have Excel or computer power to simulate so many years. Okay, just do that one. And you need to remember, you're going to use dividend 1, not dividend 0. All right, now let's work on the third question. A 10-year 4% semi-annual coupon bond with a yield to maturity of 8%. What is fair value? Okay, so let me just copy this. Control C to copy. All right, and then get to a new sheet. All right, so it's a 10-year bond. However, the coupon is paid on a semi-annual basis. So what I'm going to do here is instead of record the year, I just record the period. Okay, each period is a 6 month. All right, and how many periods do I have? I have period 1, period 2, and then I drag all the way down until I have a period 20. Okay, period 20. So I have a 20 periods because I have a 10 years, and each year it has 2 semi-annual periods. Okay, and then I want to know my cash flow. Okay, cash flow. So in the first year, every year the coupon is 4% of the face value, so which is $40. Okay, I can use 4% times 1,000 face value. That's the number by default. You have to remember that it's always 1,000 as the face value, but it's for a semi-annual period. 4% is for the whole year, and for a semi-annual period, it's half of that. So you have to divide this by 2. All right. So I'm sorry, I forgot this equal sign in front. So then you get $20 being paid for each of the period. Okay, and in the last period, not only do you receive this coupon of $20, but also you are going to receive the $1,000 face value. So your last year's cash flow is going to be $1020. All right, so that's the cash flow you will receive each semi-annual periods from year from 6 months later to 10 years later. Okay, if you want to get the fair value, you should get the present value of all the cash flows. Okay, so what you need to do is you need to discount each of the cash flow by the yield to maturity, which is 8%. Okay, and for the first year, it is $20. Sorry, for the first period is $20, but the 8% is for the whole year. You cannot just use the entire yield to maturity. That's for the whole year. You have to divide 8% by 2. So you would get a 4%. That's the discount rate for a semi-annual period. Okay, and then you raise to the power of whatever period it is. Okay, period 1. Okay, so $20 would be discounted to 19.23. Okay, and the second $20 you apply the same discount rate, which is a 4% for a 6-month period, raised to the power of a 2. Okay, that's a 18.49. Okay, and then you just drag it all the way down to see the discount value for all the other cash flows. So the price of the bond, so the price of the bond should be equal to the summation of all of them. Okay, the summation of all of them. All right. So $728. And you can also use another function of Excel to do the job. So you use you are solving basically for the present value. Okay, and you start with PV, and the rate you put for discount is 8%. Be very careful you're not using the coupon rate to discount the cash flow. Instead, you are using yield to maturity to discount the rate, and the coupon rate is used to get payment. Alright, so you're gonna put a 8% there, and however you are calculating on a semi-annual basis, so it's going to be half of the annual rate, 8%, which would give you 4%, and then comma. Then how many periods do you have? It's a 10-year bond, and it's a semi-annual, so you are going to have 10 times 2, 20 periods. And your payment for each period is going to be 1,000 face value times the 4% coupon rate. That's the annual coupon payment. You have to divide it by 2. Alright? And what is your future value? That's going to be 1,000. Alright? And the type should be 0 because you pay, the payment is delivered at the end of each period. Okay? Or you can just skip that one, skip the 0. Alright? And then I hit enter. I will get a negative $728, which is exactly the same as the last one. Okay, so the Excel recognizes the direction of the cash flows. If you receive money in the future, then today you need to pay money. So that's why you have a negative cash flow right here. So don't worry, you can just put a negative sign in front to get the fair price for the bond. All right, so that's how you do this question. And if you want to use a calculator to do the job, all right, so this is what you need to do. You hit apps, finance, option number 1, and then time value of money. Okay, and then you have 20 periods. Okay, and your interest is 8%, and that should be half of the 8%. So I use 8 divided by 2, and you solve for present value, leave it at 0, and the payment should be 1,000. 1,000 times 0.04. Okay, so that's how you get the annual coupon payment. You're going to divide that by 2. Alright, so that's your periodical payment. Okay, that's 20. And the future value is always 1,000 for a bond that is not callable. Alright, and then you move back to present value. You solve it, alpha, enter. That's how you solve it. Okay, so what I did wrong here is I forgot to change the payment method. It should be end. Okay, and then I move back. Alright, then alpha, enter. Sorry for the mistake. So what I did wrong is I highlighted begin. I did not highlight end. So in fact, the payment is made at the end of each period. So make sure you hit that and hit enter for end, and then you solve for present value. So that's how you get the this answer done for question 3. Alright, for question 4, draw a price interest curve for a 10-year 4% semi-annual coupon bond. So basically it is the same as this bond, except the yield to maturity or the interest may change. Okay, it could be 8%, it could be 6%, it could be 12%, and under each yield to maturity, under each interest, then you would have a different bond price. So what I'm going to do here is I will simulate a column of yield to maturity. I'm going to start at 0%. Oops, let me zoom in a little bit. Okay, I will use 0%, and I will let my yield to maturity increase by, let's say, 0.0 plus 0.01 or 1%. Okay, half percent. Let's say half percent, or just to put a 0.5%. It's the same. Okay, so. Alright, and then I just drag it down. Okay, as you can see, my yield to maturity is simulated like this, from 0% increase by 0.5% all the way, and I want to end at let's say 20%. Okay, end at 20%. If a bond has yield to maturity that is over 20%, this is definitely a junk bond. Okay, that's not worth our time to analyzing. Okay, so that's my yield to maturity, and I want to get the price for the bond. Okay, how do I get the price for the bond? As I said, you are going to use this function. Okay, you are going to use this function, and just copy paste the entire formula. That's fine. Okay, so highlight them all and then copy, and then if you want to paste, just double click on the cell and then paste. Okay, and then paste. Alright, so if I hit enter, it will be the same answer as the last one. Really, I'm going to change the 8% to 0%. That's the yield to maturity I like it to have. Okay, so I got a 1400. Okay, the rest of information is the same. It's a semi-annual bond. You see, I divided 2, multiplied by 2 here, here, and here, and then the same 10 years and the same face value, the same coupon rate. Okay, and then I just drag it all the way down. Okay, and then or I can double click the right bottom corner to get all the prices. Okay, so that's the data I have to create the chart. You know, the chart basically tells you the bond value or the bond price as a Y, the vertical axis, yield to maturity as an x-axis. So this is your Y's, these are your X's. So I'm going to highlight all of them. Okay, and then I click insert, and I want to the scatter chart insert. Do not use a line chart, you use a scatter chart. And in the scatter chart, you are going to select this one. Okay, this is scatter with the markers and the smooth lines. Okay, and then this chart is created. Okay, as you can see, if the interest rate keep increasing, then the bond price would keep dropping. All right, and you can also edit the layout a little bit. Okay, so you can hit this button. Okay, design quick layout. You select layout number 1. Okay, so this is bond price against interest. Oops. Okay, and the vertical axis is the bond price, and the horizontal axis is yield to maturity or interest. It's the same thing. Okay, and you don't need this legend. Okay, you don't need this legend. Delete that one. All right, and also you can edit the axis a little bit. You see your maximum of the x value is 0.20 or 20%, so you don't need 25, so put it as 0.25. So basically what I did is I double click on the horizontal axis. It's right here, double click, and then it just tells me how to edit the numbers. Okay, so the maximum should be 0.2 or 20%. So basically you are done for this Excel project. Thank you so much for watching.